I'm going to go through this question in two different ways. First way is a nice approach if you can see it, and it's like once you do this, it's like makes life so much easier. But we don't have it going through the corners of the squares or anything. But what we can do is extend the diagram to turn it into a rectangle where actually MQ is now the diagonal. So all we have to do is find the area of the rectangle, halve it to get this whole thing, and then subtract this blue square. But I didn't see it when I did it, but now, like I see it, it's like, yeah, that is a really good method. So let's try and figure this out. We've got the ML is equal to 6, and we've got the PL is equal to 4. Now, another really important piece of information is that K is the midpoint of RS, which means that this here is equal to 2. Okay, because the whole thing is 4 and it's the midpoint. Brilliant. And then actually everything else falls into place because I've got 6 here as well and 4 here. So we can do a half times 8 times 10, which is 40, which gives us the whole area, the shaded region plus the blue rectangle. Right now, here's the other thing. We have that this length is 8 and this bit is 4, so the missing square is also 4 by 4. So we just need to do 40 minus 16, which is 24. Very nice way of getting the answer. All right, let me show you a not so nice way, but we still can get there with it. Just it's interesting to compare different methods. So when I did this, over the years when I'm doing math challenge problems, often I've not been able to solve questions because I've not seen there are similar triangles. So now by default, I seem to look for similar triangles in any question, even if there might be easier ways like the one above. So I spotted that, right, I've got this blue triangle here, and I've got this red triangle here, and they kind of look similar. And they are similar because I've got a right angle and a right angle. And then this angle, I've got alternate angles here. These two are the same. I'm going to shade them in actually, which means that these two must also be equal. So we can use that to try and work out the dimensions, because if I can work out the dimensions of the triangles, then I can basically solve the problem. So this length is 6, um, and I've got 4 here. And those two sides are like they're the ones that kind of correspond with one another. You can see that the angles that are equivalent are in between those two. So I can write down that the larger side divided by the smaller side is going to equal. Right, now I've got a bit more to do. I want to work out this length here. So um, I'm going to call this small length x. Actually, I'm going to do this in green just to highlight it. Okay, I don't know this, but I'm going to call it x. And what that means is that the length of the triangle here, well, it's going to be, remember, this is the midpoint, so this bit is 2. So it's going to be 2 plus x. And then for the blue triangle, I'm trying to work out this length. So this is going to be 6 minus x. And therefore 6 over 4 is equal to 6 minus x divided by 2 plus x. I'm just dividing pairs of sides of the similar triangles, basically. Um, and I just want to give you like another example just to convince you. So let's say I had this was 2 and this was 3 and this was 4 and this was 6. This one's twice as big. Okay, they're similar triangles. So you can write, how do you know they're twice as big? Well, you can just look at it, but you can also get it by dividing the sides, doing 4 divided by 2 to get the scale factor, but also getting it by doing 6 divided by 3. That's what I'm doing here. I'm saying the scale factor is 6 divided by 4, but I can also get it by doing 6 minus x divided by 2 plus x. Okay, that is an equation I can now solve. And yeah, you can see that this is more complicated. I can cross multiply. I can get 6 times 2 plus x equals 4 times 6 minus x. So 12 plus 6x equals 24 minus 4x. 10x equals 12. X equals 1.2. I've gone through that quite quickly, and you have to be able to solve equations with x on both sides for this. But that is going to be enough actually, because now I can change 6 minus x to 4.8. And so I can work out the area of this blue triangle. Actually, I think I'll figure it out now. It's going to be a half times the base times the height, so 6 times 4.8. And I'm going to do 6 times 2.4 because that's a bit easier. I'm going to halve the 4.8. So I'm going to get 12 plus 2.4. It's going to be 14.4. That is the area of this triangle. For the red one, it's going to be similar. So I've got 2 plus x is going to be 3.2. So for the area, I've got a half times 4 times 3.2, which is going to be 2 lots of 3.2, which is 6.4. Which means the shaded region, this bit here, is going to be 16, because it's 4 times 4 minus 6.4, which is going to be 9.6. So I'm nearly there. Overall, the blue plus the green is going to be 14.4 plus 9.6, which gives us 24. So whilst I don't recommend doing it this way, I recommend the other way. Like if you don't see to draw the rectangle, then this would have worked. It's longer, more complicated, but it again gives us the answer of 24.